been noticing ever since our Honorable Vice Chancellor has taken charge as the Vice Chancellor of this university. And you may be knowing that all the institutions are classified into categories, Tier 1 and Tier 2 and Tier 3 kind. All the university colleges or universities and IITs and IITs are supposed to be the Tier 1 institutes. The Tier 1 institutes are supposed to be research-driven institutes. And our Honorable Vice Chancellor has noted that though it's branded as bracketed as a Tier 1 institute, it has been noticed that the activities of our university are confined to only teaching activities and consultancy, but not much of it to the research. So thereby, as a result, he tried to inculcate, infuse into the each and every of the stakeholders of this university a research mind, a research culture, research attitude. And as a result, to take an action to get this be inculcated into ourselves. One of the activities is that this conclave and also this symposium. So symposium for the researchers. Probably you might have also noted that all the research scholars are given university email IDs with the demonic university domain. So whatever that work that you carried out, it has to be published. It has to be useful for the society. And also the university contribution also, university name brand also has to be reflected in the publications. And also, it's very much known that most of the research findings, creativity, is always happening at the interaction of the individual, individual and interdisciplinary. So as a result, you are invited to present your work as a poster presentation. People will be testing, people will be visiting your work and interacting with you. They may also get excited and interacting with you. And they will also give some ideas to improve your work also. So in this connection, we have a speaker with us, Sridhar Garu. He will be speaking today because enlightening on the burning and the latest topic like the quantum computing. So thereby, let's be benefited. And then also I sincerely advise to all the research scholars that this context reminds me that sometimes during the course of your pursuit of your PhD, you may be disappointed sometime at point of time. So we have to realize that research is something like a journey from known to unknown. It's an untrodden path. As a result, sometimes we may encounter some difficult situations, we may get disappointed. So thereby, just I wanted to remind you some small anecdote. The research is something like an attempt to finding a black cat in a very dark room by a blind man with blindfold, probably on the night of the Mavashia. I hope you got it. I repeat it. The research is something like an attempt by a man, a blind man with blindfold, to find out a black cat in a very dark room on the night of Amavashya. It's all impossible. Perhaps the cat may not be there. So even in that situation also, we should not be got disappointed. We should carry our research work and we should benefit. We should contribute to the society. All these facilities that we enjoy is the contribution by our forefathers and the people who contributed it. So being benefited by these benefits given by others, we should also give some to this society. So with this few words of relevance, I wish all the research scholars will be benefited by interacting with these sessions and also bring name and fame to this university. So I also congratulate the organizers for having wonderfully this very conducive environment for the encouraging the research. And with these few words, I thank all the organizers for giving me this opportunity. Thank you very much.
About the importance of HPC, high performance computing. If any some of my colleagues can remember easily, in 2016 itself, we invited Rajkumar Bhaiya, conducted the Kuda HPC program. Some of the affiliated colleges utilizing the resources established in the Department of Computer Science. They published the paper, right? Now, Kuda is completely GPU programming. GPU became number one. That's why NVIDIA is rocking like anything in the share market. Right? Now, I request our Honorable Vice Chancellor, Sir, Professor CSRK Prasad Garu, to address the participants.
Good morning, to all. Definitely, I'm not going to speak about the share market. I hope I'm not disappointing. The respected chief guest of the today's function, Sridhar, was just asking him, leaving the lucrative job in the TCS, for you to take a bold step in joining the state government, because it's always challenging for the person working in the industry back to the bureaucratic world. It's not easy. Probably, I hope he's going to throw some light on that also, because challenges for facing. Thank you, sir. Thank you very much for joining us. So he is a key man and leading from the front, implementing realizing the vision of the honorable CM, making Amravati as a quantum valley. So he is heading that mission. The state quantum mission is the CEO of that. I thought that when we are conducting a symposium, the second year in sequence, so immediately Sridhar came to my mind. He is the right person to address and ignite the minds of the scholars. How many of you have attended last 2 days conclave? Please raise it. A very good number. Good. I appreciate it. So there are some questions among the audience. Yesterday I gave my mind why we are conducting a conclave and a symposium in sequence. When I took the charge as the Vice Chancellor of JNTUK Canada, I know that the University College of Engineering Canada, which was established in 1946, is the oldest engineering college in the combined state of Andhra Pradesh along with Andhra Pradesh. UCK has an excellent track record of the teaching and research college. Now it has been upgraded as the university in 2008 with a lot of burden, unbearable burden on the faculty members in the form of about 200 plus affiliated colleges. UCK, now JNTUK, is a Tier 1 university. As for the national education policy, there will be 3 types of universities in India in the next 10 years. As you all know that there are 50,000 colleges across the country which are being affiliated to about 1,200 to 1,300 universities in this country. The same kind of a bureaucratic process, dependency on the university system, etc., is going on across the nation. So they realizing this, they want to classify and upgrade the universities into 3 types: research intensive universities or the Tier 1, teaching intensive universities as the Tier 2, autonomous degree colleges with a authority and power to award their own degrees. It means that these autonomous degree colleges are having their self-governance. They can formulate their own rules and regulations. They can formulate their own syllabus, schemes, degree programs, etc. And they can award the degrees. But they will be restricted to the UG only, UG programs only. So all these 50,000 are, for example, in case of Andhra Pradesh, with respect to JNTUK, there are 160 accredited colleges. All these colleges has to disappear. They have to get independence. Either standalone or group of colleges can come together as a cluster and form as a affiliated college or the autonomous college. The second tier is the teaching intensive university, where the faculty members are expected to spend about 60 to 70% of the time on teaching, the balance time on the research. And tier 1, like JNTUK Kakinada, all IITs, all NITs, IIITs, ISRs, centrally funded universities, they have become another tier 1. Their faculty members are expected to spend about 50% teaching and 50% research. Please note that teaching is not compromised at the cost of research. Teaching is our priority. Whether it is affiliated college, autonomous degree colleges, or teaching intensive universities, or research intensive universities, teaching is the priority. Teaching, imparting good education to our students is the topmost priority. The research is expected to complement the effective teaching process. This is the whole philosophy of the education and the essence of the National Education Policy 2020. When I try to look into the IIT centrally funded institutions, yesterday also some news came, about 3% of the centrally funded institutions are capturing 50% of the R&D funding in this country. We're all in the remaining 97% of institutions. Okay? 3% of the institutions in this country belongs to the IITs, NITs, etc. They're capturing 50% of the research funding. Like all the centrally funded institutions have the direct fellowship. For example, NIT Warangal, every year they will advertise for 200 positions. They can admit 200 research scholars every year. Every scholar will get a stipend, about 35,000 per month. And balance after second year, they will get another 40,000 plus. Plus some fringe benefits are also there. But what happens to the scholars in this central state funded universities and private universities? This is the issue. This is what I realize is the major problems about the quality of research happening in our university. Most of the scholars are part-time scholars, right? No direct scholars, or any direct scholars are there. Full-time scholars, one. So only one full-time scholar. What is your name? ఎక్కడ చేస్తున్నారు? ఎక్కడ? Okay, good. So now, of course, university side also, we are also thinking of introducing the full-time fellowships using the university funding. When I try to look at the part-time scholars, they have been scattered across the colleges. I know we're all loaded with the teaching as well as administrative jobs, the multiple tasks ready on college. So after exhaustion, both physically and mentally, you try to squeeze some time to spare on your research stuff. Equipment might be available, not available, resources are available or not available, this is a situation. Then I thought that I should create a platform for these scholars to come together at least once in a year. For RRMs are there once in 6 months. We are going to make it seriously because I understand the false impression that both the administrators as well as the scholars that 2 RRMs are sufficient, etc. It's not correct. Every semester, the progress of the research scholars has to be assessed before registering for the next semester. I think my director of economics might have communicated you properly. Otherwise, please take it from me. That your work will be reviewed once in a 6 months time in the month of June or July before we are registering for the first semester of the academic year. And at the end of the first semester, again, your performance will be reviewed by the committee, and RRM committees are also going to be changed shortly. Next year onwards, you will not have any single RRM department wise. We have specialized wise RRM will be there. If you have civil engineering, structural engineering, specialization RRM will be there. Okay. Similarly, environmental engineering, similarly geotechnical, like that. So specialized wise you will have it so that you will have more focus experts that RRM. So relevant to your area of research. They are going to be. So twice a year your performance will be evaluated. But that's not sufficient. What we thought is you have to create a platform. So that is the reason why yesterday and day before yesterday we have conducted a technology conclave, completely focusing on the scholars. I have not invited any faculty members. I invited only scholars. And faculty members other than the scholars also can attend. But I am very clear. My objective is the focus target group is the scholars. We have chosen through the lot of exercise and identifying the topmost scientists in the country. Requested them to, I didn't say that this topic or that topic. I said that based on your expertise, you take a topic, you tell us complete story, what is happening in this nation, what are the research problem statements, and what is the future in that domain. So that, and you might be thinking that I am doing only structural engineering and civil engineering. Why should I hear about the topics other than the structural engineering? The idea is we are not alone in this world. The society is becoming complex, problems are also complex, and they are going to become multidisciplinary. They are already becoming multidisciplinary. Probably Sridhar will throw more light on that also. So, in that sense, every one of us should have an open eye and understand and hear what is happening across the globe in different domains. That's the purpose of the conclave. The research which is happening in the meteorology or the material science or oceanography or agriculture may give some idea, trigger some idea in our area of research also. The tools or techniques which are available, employed in different areas will also may help us. You can also adopt them in your area of research. This is the purpose for which we have arranged it. This technology conclave will continue because I may get another opportunity 1 year next time. The 28 May I may not be available. I hope my colleagues, my young friends will continue the technology conclave. So the second technology conclave will be there next year also on the 9th and 10th May. Please mark the dates. The second purpose is the symposium. This is the second research scholar symposium. Last year also we have asked the people who have completed 3 years of time registration. You might have done some reasonably good work. So want you to give an opportunity for you to present. And then try to understand, interact with the scholars who are working in the same domain and what they are doing, how they are doing. Probably you can have self-assessment. You can have your introspection, whether you are doing good work or what is the quality of work being carried out by you. We saw this with respect to the other scholars who are doing in the same domain. So that will enable you to have an assessment, to look into your inside and to assess your quality of work. You don't require any judge, right? We are all intellectuals, we are all the teachers. You are already evaluating, assessing the students. Hundreds of students you might have already assessed it. So now use the same technique to assess yourself honestly. Be honest with yourself and assess your quality of work. My concern is the research limiting to the thesis books, limiting to the or book ranks is not good enough. Days have gone. Days have gone. These are all because we're all teachers. We're always doing an academic research. Most of us might be thinking that by doing the PhD, I'll get the eligibility to get promoted to associate professor or professor. That's the target most of the cases. But those things may not be sufficient. We need to take the problems which are realistic in nature in the society. What are the problems available, and we should be able to provide a solution. Get the solution, and this solution should be implementable. That's what the government of India is thinking. Now the entire scientific world thinking is that what are the case studies where you can apply your tool and can implement it or not. This is where technology readiness levels 1 to 9. You might have seen that yesterday. You might have seen. I think Dr. Professor Narsingrao has demonstrated a slide where our academic research is in the TRL 1, 2, 3 or maximum 4. Now I request you to think whether you can extend this, take this to the 4th, 5th, 6th level and develop the product and demonstrate it. Can you market it? Can you go for a patent and market it? And can you transfer this technology to the industry for the implementation? So that is the direction in which the research is going on in all centrally funded institutions. Don't think that patenting is a big thing. Don't think that marketability, developing a product for the marketability is a big thing. It's all our mind. We are not being habituated or forefathers or earlier process or the systems are always conducive, is acting on mind, saying that do some research, publish something, get your degree, get your promotion like that. Beyond that, we are not thinking. Please start thinking in that direction. We have all of us has that ability, capability to do that, to take the product to the next level. So in that respect, thanks to the state government, has established Ratan Tata Innovation Hubs at Amravati and spokes at different locations. And JNTUK is also a knowledge partner. The one beauty of this is they are involving all the universities as a knowledge partners. All the major universities, like JNTUK is a knowledge partner to the spoke at Rajahmundry. Each spoke has a domain, like is a green hydrology, agri-tech, and food technology. These are all the areas. Doesn't mean that they are not applying the quantum technologies, quantum computing, or AI and ML, etc. These are all the domain areas. Tools can be anything. So like that, we have the different scopes. Every one of you have a bright idea, your own idea, or with your scholar, or with your students, your own idea. You can always incubate at your college level, and then can we take it forward to the any one of the scope, and then the funding is available. Funding is available. JNTUK Kakinada is also bringing out, thanks to Professor Murali Krishna, Gopal Krishna, is bringing out a document on the policy document. We are going to finalize that. So there is a scope from the university also for the scholars to fund it. And we're also seriously thinking to fund the research scholars to attend at least one international conference within India. Foreign I cannot provide right now, but our directors have taken decision, our apex committee members. So we are going to fund each scholar, at least in your tenure. You can attend an international conference within India. All your research to be travel will be taken care. The idea is you want to interact the peers and the experts in your domain at that level and present your work. You have to present a paper, present your work, and then get the feedback from the experts coming from the different areas of the country as well as the outside country. So with these few words, some more things are also there. We'll share you subsequently. With these few words, I hope you will present your work, interact with your colleagues who are our friends who are working in the similar areas from the different colleges, and try to learn, try to improve the quality. Don't think that you are doing research for somebody's sake. you are doing for yourself. Actually, in higher education, it's a self-realization. The whole purpose of the higher education is self-realization, knowing ourselves, knowing the truth. So that is the basic purpose. And then subsequently, you should be able to address at least one societal problem in your domain. Try to find out a solution. Then prove yourself that you are something to this society, to this country, or to this state. Thank you, Anand.
Thank you, sir. VC sir. Now, I request our chief guest, Peter Garu, to come and say a few words. Afterwards, session will start after 5, so that we can answer comments and have the session.
Honorable Vice Chancellor, CSR Prasad Garu, Dr. Subbarao Garu, Dean Academics, Vishnu Prasad Garu, dignitaries, the audience, professors, research scholars, students, and my friend, Krishna, also. Good morning to all of you, and thank you for having me in this conference. So on this auspicious day of National Technology Day that we celebrate on May 11th, I'm very happy to be here. And I congratulate JNTUK for organizing this important Research Scholars Symposium. And I'm very happy to be part of this main function. So very few occasions I see at the state level, we talk about research, right? And this is the first time I'm hearing at a university that we are talking more about research. And I'm very glad to be part of the community of researchers sitting in this room. Thank you so much, sir. Actually. Thank you for your words, inspiring all the students about their path, their research. So my association with research is about a decade old. So I'm part of TCS research. So when the company merged with TCS, so I moved into a group called TCS Research. And again, I just have to say a few words there. So at TCS Research, so we are organized into 3 groups. The first group is the research itself. So where we think what TCS should do beyond 10 years. The second group, which is called innovation, that comes next. So here we see what TCS should do in the next 5 years. And there is also a third group, which is called incubation, so where I used to come from. So here we see at how do we collaboratively take all the research and innovation efforts to the market. So we try to take all the efforts that are coming from the research. We've been working on a single problem statement for long duration. And then that is transferred to innovation team. So we should try to bring the additional capabilities that are required to commercialize this. So this is the stage where we are moving to higher clearance, right? And then it is given to an incubation team. So that will go and hit the market and make sure that the product is commercialized. So this is the typical life cycle in which I was brought up. So I worked on some of the research teams like UAVs and drones, robotics, worked on AI, worked on Internet of Things, cybersecurity, etc. But significant boost came. So when we started a program for building India's first quantum computer. So this is way back in 2018. Again, as we look forward into what TCS should do beyond 10 years. So we also look at what is good for the country. So we sponsored a program through TIFR in partnership with DRDO for building India's first quantum computer. So this is a 6-qubit quantum computer. Again, So we have no clue of what is going to be built there. At a high level, we know, I mean, it is as good as, like sir mentioned, it's finding a black cat in a black room, a dark room on the Amavasya day. It's like that. Very blind man. Yeah, but we have a very nice professor at the Affairs, Professor R.V.J. Raghun. So who took this initiative and then built India's first quantum computer launched it in 2024. And when this computer was launched and the announcement was made, we have more hits from our neighboring countries than from India. So they are watching more about our research than what we are doing ourselves. Yeah, but the point is, it gave confidence that we can build quantum computers, and there is a lot of capability within the country, so we can harness all these technologies, but it requires a different set of mind and bring all these people together to build great products. So this is about taking a research idea into higher TRL levels and then making it an innovation. But that is not sufficient. So because most of the prototypes that we build will lie in the labs most of the time, right? And these innovations or these research outputs would require a lot of funding, a lot of national support to take them to higher TRL levels and take it to the market. And that is where typically we struggle today, right? And this is what we want to change going forward. And I'm very happy to see all the research scholars coming together and discussing the ideas of building such great technologies. So we have many problems in the world today. I'm going to talk some of them in the presentation. I will speak, right? So I want to tell one more story at this point of time. So when I returned back to returned from the US for good, 2015, so I visited all the colleges there just to understand what is so great about this country, right? So here, there I visited all the colleges on the East Coast mostly. So I went to Princeton, Yale, MIT, Harvard, then came to Colorado, then Stanford, and all these places. Each university is about 100 to 300 years old, and all these universities boast about some of the great products coming out of their university. They also talk about people. So they say we have 4 senators coming out of this college. We have 10 presidents this college. We have 5 Nobel Prizes coming to this college. So this is what the colleges boast about. When I come back to India, I work very closely with JNTUK, where I graduated from. So I was just trying to think. So college is about 50 years old because I was a single GD. And then 11 GD, sorry. And then I was thinking what is missing here, right? So most of the colleges, I think the reason why this occasion is also special is getting the scholars together is the missing link is the research part. So once you have the research part, the rest of the things will also be easier. And this is also the problem for the country as well. So in the country, so we are always said that we invest less in research compared to other countries. Our research investments are about 0.65% on the research of the GDP. And very few companies invest more than 1% into the GDP. There are very few companies that invest greater than 1%. So TCS invests 1.37% into GDP of the total revenues into research, and that creates natural business outputs. So all the efforts that all of you are putting in solving particular problems will definitely translate into outputs, and these outputs should be enhanced with other interventions. So that will come from teams like innovation or teams like incubation, which are going to support all of you in making these research outputs into products and solutions. So we'll take an example like the 1930 or 1920. But we have not commercialized that technology enough, like the Germans did. So they've taken the same technology, commercialized it enough with all the medical diagnostic devices, right? So today we are building prototypes, but we are still not, we don't have a world-class product that we can claim that this is the best medical diagnostic. But that is not impossible. So we are all coming to tier level 3, 4 easily, but somewhere we are stopping there. We're not getting further deep into it, right? So this is something that we need to change, and it requires a bold vision, the vision that our Honorable Vice Chancellor presented today, how the academics should be structured, how the hierarchies should be structured so that this can be supported. Then only this can be achieved. And to support this, support at the next level, right? And that is where we have a problem there, and that requires a solution. And I request all of you to think through this one. So most of our students in the undergraduate level,
Ikama
very
enni kathi
curious about-
kodtan right. The tiffin anna.
very curious. So if you ask them, so probably most of them might not be knowing quantum about
Akkada petti anni
but today you ask
kodtar sara.
anyone in Andhra Pradesh,
Akkada petti.
they are fully aware of one. But curiosity has taken them to awareness, so they learn very nicely with quantum, right? So this curiosity translated to awareness has, with some efforts from government and people like you, to inspire them. So these three stages we are doing very well. The curiosity stage, awareness stage, and the learning stage, we are doing very well. But what's happening is here, we are following. The moment you learn something, you're getting a job. And the intent with which we are going to college is to stop here. Just learn and get a job and move on. Right? And that is the problem here. Right? And it should not stop here. So it should actually go to the next stage. So where you can explore, experiment, and then work with other researchers like you, and then translate that into either a research output or an innovation output, and then subsequently get that to a product. So this entire cycle we need to
But
complete.
Pete,
Then only great products will come out.
Tiffin
of
anna.
it, right? And what we are stopping here is
Tiffin
we're
cheyadam.
stopping at the learning phase, which is natural because all of us are getting jobs there. Many of the students, many of your students are getting jobs there. Then we don't move to the next stages. And this requires a change.
Akkada petti.
And this change can happen only when you inspire them for doing these experiments and explorations. So which would also require a lot of effort from the institution in terms of pushing them to work on these kind of areas and themes and inspire them with great facilities and laboratories. And then we all can work together to build a nice
Register
ecosystem.
gariki meeku pettan.
So that can
Register
build
garu kuda
products
pettan.
and solutions for everyone. So we are actually very good at putting solutions for others, right? But we don't do original thinking. Or we do original thinking, but because we are happy with getting a job, so most of us stop there and then we don't continue the path forward. So our Honorable Chief Minister has taken a session on December 23rd to all 50,000 students who are attending quantum technology stream, right? And he came and said, so we will give 100 crores to the people who can win the Nobel Prize. And how do we win a Nobel Prize? Is the question. So after that, there's a lot of debates in TV channels.
Mari annaru taatvaru.
He thinks around 100 crores. Now,
Hmm?
with that, will be invested in education or
Kaadu test adi
for
annaru.
students to win this, right?
Tiffin
That we
lera.
leave it to the debate, but the point here is,
Mari annaru.
in order to win a Nobel Prize, so we need to go beyond learning, the traditional learning,
2 varalu.
and we should start utilizing the technology,
15 రోజులకు ఒకసారి.
experiment and explore, and that is what you can facilitate and you can do things here, right? And inspire all the students to do that. And typically, you see, they are very fast at experimentation.
Huh?
So I used to work on some hobby projects, like a food sensing technology, right? I use a sensor called
ఎప్పుడంటే అన్న చెప్పారా
so which is from a Bosch.
అన్న చెప్పారా
Bosch, the age sensor. Design quality, it also gives many other parameters, right? But it requires laborious experimentation cycle to arrive at qualifying the taste of the product or the smell of the product, right? And I used to take a lot of interns from colleges. So they do one cycle, after that they know the learning, so they get a job and they go away, right? So what we need people who can dig deeper, go further and build a product out of it. So that is what we would require. And this community here, I think this the force here is really helpful for achieving such kind of vision. And if we translate this entire thing into a nice cycle, a nice virtuous cycle. So we have researchers at the top, I think supported by students, we will also do something beyond learning. And then if you apply all the ecosystems that are available, like the Tata Innovation Hub or the Conclave Innovation Hub. So all these things together, so that is when we create great products. And that is when we will see good economic output. So this is possible, this is doable, and we need to do it. There is no way that we can escape this. And given the AI, which is generating outputs like anything, so it's a time that we also shift some of our methodologies. So AI is also going to transform the brain, also transform the research, and we have better methods of research now. And it is writing better papers than what we write humanly, right? So taking all these outputs, so it is time for us to build the great products for the country and also create sufficient market within the country to use those products and then generate significant wealth for the country. So the emphasis is very clear from the state government that we need to move from the services cycle to the product cycle and also build the innovations. And this is where Amravati Quantum Valley is very special. So here, so while we have 5 pillars, the most important pillar is building the hardware components. I'm going to talk something about it in the coming slides. But the emphasis is on building products and solutions than doing services for others. And I request all this community to support in this initiative, motivate all the students in this city, do world-class research, define world-class problems, and then work on these problems, spend good amount of time, and let's create some great things. And thank you for giving me the opportunity to talk on this inaugural session. Thanks so much.
Now I request dignitary Sampradaya, please join with the audience so that everyone can concentrate on the session.
Project plan. Present. Present.
How many of you have heard quantum a year back? The 100-year-old topic. The 100-year-old topic, and it's not very new. So I'm sure I must have heard, everybody, we have studied in our chemistry classes and physics classes about the subject. So as such, the subject is not new, but the changes that are happening in this are new. It's also growing. They're also creating some very new opportunities for all of us. So I'm going to cover the topic from a very, very research and innovation perspective, so that I think most of the times I make an attempt to make it not technical, so that people understand easily, and then you can go and tell your parents also. So that is the effort that I try. But you are researchers, I can talk to you in a very technical language. So let me say. Okay. So we have 2 hands. So these are binary, 0 and 1. Now imagine a scenario we have multiple hands. Let's words. In our Hindu mythology. So we have right. So yeah, I never asked this question when I was
నువ్వు చూసుకోకుండా నువ్వు వేరే చూసుకుంటున్నావు.
But you say it is possible. And we have multiple hands.
ఈ మీటింగ్ రెడీ చేయకుండా నువ్వు అప్పటికప్పుడు
Do multiple things. Right? So imagine now
Okay,
you're playing
Saturday,
chess or multiple chess boards.
హలో
Right? So you can play chess with one hand.
మరి ఇప్పుడు వరకు ఏం చేస్తావు నేను చెప్పేంత వరకు నీకు
You
క్లియర్
have to play multiple chess boards. You have to chess some experts
అక్కడ
say,
కెమెరా నువ్వు ఇవ్వాలి కదా
they
వీడియో
go and
ఏం చేయాలో
explain
decide
multiple
చేసుకో.
boards by their mind. But now
అది
you
తెలీదా?
have multiple
అసలు
hands together. You can actually play at different locations also, and you can do very, very interesting things. So those are the possibilities when you have multiple hands, right? And quantum is such thing like that, right? So in the traditional world, what we are looking at is bits, which are zeros and ones. In the quantum world, we are looking at multiple possibilities, and those are called qubits. So which is nothing but more than 0 and 1, and it can exist on any surface. So this is an example of a worker with multiple hands. The worker has multiple hands, he can do many things. And this is what we are trying to do with quantum computers. So quantum computers can do many things simultaneously. So it can do large number of calculations on a big surface, and that gives good compute power. So we can accelerate AI significantly. So we can do many more interesting things once you have this kind of capability. So you can imagine solving any of your scientific equation, any of the particle differential equation, very small amount of time. Right? So this gives numerous possibilities. We can think that qubits are like having multiple hands. So we can do many more things than doing with hands. So some foundations. So these are some common things that you'll hear when people say quantum. So in classical world, we call it as zeros and ones, these are called bits. Do sequential processing. We also do multiple or the GPU capability with parallel processing. Whereas in quantum, so it is inherently parallel. So we use something we call some sort of qubits here, which is zeros and ones, and it does exponential scale. The interesting thing here is it gives exponential or quadratic speedups, means a problem that can be solved in 2 power n operations can be just solved in n operations. And a problem that can be solved in 100 iterations can be solved in square root of 100 with 10 iterations. So that is the power of quantum. So when you try to create that kind of speeds with quantum physics and you apply that and make a quantum computer, so that's when life becomes very interesting. So it fundamentally uses 3 principles. There are many more principles, but 3 are very common. So the first one is superposition, where a particle exists in multiple states. We studied multiple times. It's like a coin spin. The coin is spinning. So we don't know if it's head or tail. It's actually in multiple states. It is actually simultaneously in both head and tail state. When you have multiple coins like that, all these coins are exhibiting different states. And when you entangle them, so when you connect these coins together, you create many more possibilities again. Then we have got a concept called entanglement. So which is nothing but a twin effect. So where you make action on any one of the particles is simultaneously replicated on the other particle with respect to the distance. For the next 1 minute, just keep that here, but again, these are not required for real quantum computing. The third principle is interference, which we study in wave, sound, and light principles. Where we see the interference creates effects, and these interferences can be harnessed to calculate maximum and minimum. And this is inherently used by computers to calculate the maximum and minimum. So in all these cases,
కెమెరా
so
ఉంది
we're
స్కూల్
talking
మీద
about
పెట్టచ్చు
creating
కెమెరా ఉంది కదా ఒకటి
models, ability to solve some of the complex mathematical equations. You can imagine a Fourier
కొత్తది ఒకటి
transform
ఉంటది కదా
that can be solved using
సెటప్ చేయడం నీకు వచ్చా లేదా ప్రసాద్ పిలు సెటప్ చేయమని
you can solve the same program by simulating the same
అలాగనే
Fourier
సెటప్ చేయమని
effect, and then try to arrive at the
టైం
result.
లేదు అరగంట ఉంది చూస్తాం
So you can imagine a sound wave, you know how the wave behaves, and again translate that to Fourier transform and solve the problem. But this, instead of representing the Fourier transform, you actually use the wave to arrive at the solution. So that is what we are trying to do in quantum. So these principles, people have never captured them and then started making machines. That's what the computers. So this can give quadratic or exponential speedups, and that is the reason why everybody is interested in this technology right now. And over the last 10 years, people have realized that this is coming very close to real. So they're able to generate these quantum effects with different technologies. So there are different methods in which these quantum effects can be generated. So people started working on these technologies, making these machines. So why this is important at this stage? So why everybody is talking quantum? So the reason primarily is all the countries try strategy, very strategic technology which can be gains. They're all talking about the AI and data centers that are significant amount of power. So now in order to do this differently, so we need to harness other forms of computing also. And one such computing is quantum computing. So which means we are not moving away from existing traditional computing. So we are adding a compute called quantum computing. Other computing methodologies like geomorphic and biocompute and many other computing methodologies are also evolving. But one technology that is standing out is quantum. So today, about 30 plus countries are investing in this technology. 30 plus countries are considering this as national issue. India also has got important issue. So in 2025 alone, a good amount of VC funding that is happening in this space, so which means a lot of companies that are set up on this technology by professors like you, right, or by PhD students like you, to set up these companies, and they are actually working and building these quantum technologies. Right. So there's got multiple things also. I'll come to that shortly. So it's growing very fast, and it has got significant jobs right now. So we have to go to a site called QETC and see all the job openings globally that are available in quantum technology space. And by 2030, it is expected to create about 250,000 kind of jobs. All major countries are investing. So China with significant investments, Germany, UK, US, Japan, India, all are investing into this technology. And some of them have got natural advantage of investing into this technology because they have some of the best labs which can build lasers, photonics, superconductivity, and all these things. So while some countries are very new to this one. So there are also a lot of alliances that are happening in this space. So all the top Fortune 500 companies are working on this tech. And many of these companies have got small teams, about 10 PhD candidates working for these organizations, like pharma companies, like Pfizer, let's say. So they have a group of about 10 PhDs who are working on how to create next generation drugs. So all the companies, Fortune 500 companies, are investing in hiring PhD candidates for building this technology. Right. So there's opportunity for all of you. It is one of the fastest growing teams right now. So compared to any other technology team, so while Gen AI and AI has taken all the main attention, the quantum is silently creeping under it. Right? And this technology is being invested heavily. A lot of strategic investments are happening from defense by many of these countries into this technology. And it's also very useful why we are doing it. So what people have done is, so in order to produce those quantum effects, so they try to create technologies using different methods. So these qubits are generated using the 4 common themes that many of them use. There are many more methods. In India itself, I've seen scientists who are working on different kind of varieties. So first, which is very common, is superconducting effect. So here are a bunch of companies which are working on this technology, like IBM, Google, Vikasit, Microsoft, IQM. So these are some of the very popular companies, everything out of India, but we also have an Indian company now, so which is called Qubit Force. The second technology, which is very common, is the neutral atom-based technology. So here we're trying to use lasers to harness atoms and try to capture these atoms in a closed space at extremely low temperatures, that are laser cool temperatures. And then we create this
quantum effect. And these neutral atoms are used to make quantum calculations. It's very good for solving graph type of problem statements. It's also very stable technology. So some of the companies are working on this one. So we have a company in India working on this technology. So there is another class of technology which is the expectations are maybe this technology will supersede or outperform all the other technologies in future, which is based on photonic capability. So here again, a very nice company are working on it. Another is Confluence, which is an Indian company, which is working on this technology. Here we use photonic effects to generate quantum, and then using that, we are trying to do that, or we are trying to do the computations. Last technology is Swarnandhra. So again, very nice company. So actually, this is one of the first technologies that was started by Honeywell, and they are working with another university, Cambridge University, and right, and then that is a tracker on this computer. It's called Continuum, and we have other companies like JNTUK who are making it. So these are 4 commonly available technologies. These machines are real, so they are available. So each one costs anywhere between $100 million or maybe more than that. So the one that we're getting is about 10 crores. So these are the machines that people are working on. So right now, the opportunity is there in building these kind of machines. It's not easy to generate these kind of machines because you will see the interdisciplinary nature of this machine size. So this is an example of a superconducting quantum computer. So we have recently launched one similar computer in Amravati, which is exactly the same machine, almost the same. So the company has brought in experts from IBM who participated in building that system. That is an indigenous portion of the system. So this is an IBM 27-qubit quantum computer. You can see different components. So here you have the processor, and this attaches to the dilution refrigerator. Gradually, and then you have a nice magnet here, and then you have RF cables, an amplifier, and temperatures, all enclosed in a copper and aluminum chamber with the heat exchanger here, and this wires will pass through like this and are connected to a bunch of control systems, so which is nothing but control electronics. So bunch of FPGA boards that are doing the control, right? And the cooling effect comes from another system, which is a helium gas chamber, which is connected to this one. So we use helium 3 and helium 4. So we need 6.6% of helium 3 mixture to generate temperatures. So here we can go up to a temperature of minus 273, close to minus 273, millikelvin kind of temperatures. So in order to generate superconductivity effect, you need about 20 millikelvin. To generate 20 millikelvin, you need that kind of effect. You need a mixture of helium 3 and helium 4 mixed at 6.6% using a very specialized chamber. The heat exchanger is there at the top. So which continuously pumps this to this one. It is a recycled machine, so you are not losing helium here, but the system operates nicely. In 36 hours, this entire system will cool to minus 273 degrees, and your processor generates a superconducting energy. And that qubits that are there, so are continuously measured, and we load our problem statements using software and then run on the system. So this is an example of a superconducting system. So let's take one example here. This is exactly the machine that we built in Amravati. So I would request all of you to come down to Amravati. We have 2 such machines that are installed there. So please come and have understanding of this one. So you'll see a lot of interesting technologies that went into this one for making this kind of system. So here you have flanges which are copper coated with 20 to 100 nanometer silver particles, right? And it is using a special deposition technique. So we have actually put this of silver coating on this flanges, right? Yeah. So the point here is to build such a system, right? And you think one professor can do it? So there are multiple technologies here. So you have a bunch of electronics that looks very complex. Right? And myself, I'm from electronics background, I'm scared of looking at the electronics that goes behind. Right? And then we have the processor, which is again designed in a in a fab, in a common semiconductor fab, which is nothing but silicon carbide on the silicon wafer. So we got this aluminum deposition done and we build something called Josephson junctions. And that acts like a processor here, right? And then we have these flanges which are manufactured, and we have these cables which are operating at different temperatures. So your cable should work at -270 centigrade. And what we learned is -270, there is no matter, nothing exists, the resistance is zero, all those things we are studying, right? And how do these cables are carrying the signals? So we have an amplifier and attenuators attending at each stage. And these are at different temperatures, which means they can also add a lot of noise. Right, and this noise should be managed. As you manage this noise, control systems again. Right, and then you have these chambers which are nicely sealed. So if you don't design this nicely, so you will lose this helium gas that is inside this one. And a liter of helium gas costs about $5,000. So there is one lose some 2 crore rupees overnight. Right, so the system should be designed to perfection. Right, and then you have all the associated, and this system should be extremely stable. So you cannot have any vibrations in space. So it should be operated in an extremely stable environment and should be patient for 36 hours to get the system cool. Right. Okay, so it is generally put on a very vibration protected environment. So what we are building at Amravati Water Valley is a very special building that is coming up, right? So we got all these vibration protectors that are there under the surface of this machine. So when we put this IBM quantum computer there, so it is on an isolated environment. That room is protected by German technology with vibration isolators. We will do that building. Yes, I'm sure the building of sometime. So yeah, the concept here is you need multiple people to come together to build this technology. Right? And what the startup in India has done is they got a professor from PFR to build a processor, another professor from IIC Bangalore to supply the other processor, because we have two systems. And they made this entire dilution refrigerator. So they got these cables from a professor from IIT Bombay. Then the coming from PFR. The control systems are coming from DRDO. And this and the helium gas and other things. We got it from a company called Amber Enterprises, so which is India's largest manufacturer of air conditioners. So that's another company that contributed in this one. And collaboratively together, they built this entire complex machine, which costs about 15 crores. Right? So this is the Indian version was built. I should have put the photograph, sorry for that. So an IBM computer costs about 1,000 crores. Right? But the Indian version costs for a smaller number of qubits. You should not make direct comparison because IBM systems are extremely powerful. So these are 150 qubit kind of machines. They are state of the art and there's a lot of engineering that might take place. So good amount of engineering also happens in the processor here because in processor you have to cover every pin to the every other pin. You have NC2 combinations. So every of these bits should be nicely connected. And those wires should come out. And control systems will also linearly scale. So if you're talking about 1,000 qubit, huge amount of electronics surrounding this machine. And then thousands of wires coming out of this one are adding noise, which also generate heat and this. So extremely complex engineering that is happening here. And a multidisciplinary team of professors were coming together and then created the system. And this is the system that we have. So the point here is, so these are so complex systems, and many of things in the world are very complex. If you try to build only one part as a part of the research, you always get a doubt who will buy this product. Where is the market for this product? Right? And you have so many questions that you are going to get.
ఈ వాయిస్ ఇక్కడ నాకు వినపడాలి కదా, ఈ స్పీకర్ లో రావాలి సిస్టమ్ స్పీకర్ లో రావట్లేదు.
Say that who's the customer, like the technology, but who's the end consumer, right? And this is where it requires good collaboration to understand what are the requirements of the system itself, right? That system.
ల్యాప్టాప్ లో వస్తుంది ఇది మైక్ ఉంది కదా, ఈ మైక్
And this
పెట్టి ఆడియో
was built in India. So we realized that we're facing
అదే
challenges
చూడు
with 2, 3 problem areas. The first one is about
హాస్పిటల్ జాబ్
working on with copper flanges. So this 100 nanometer particles.
ఆ మైక్ దగ్గరికి వెళ్ళి
There's no
తీసుకుని మైక్
country that
దగ్గరికి
is
మాట్లాడి
in India that is doing that. So if there's a got this.
ఆన్లైన్ కూడా కొంత
Another system, another company in Delhi to do the deposition. Right? So now we've given that as a problem statement. So this is a problem statement that they produce. Some university in India should actually produce this. The second part is the helium gas.
ఆన్లైన్ పడుతుంది కానీ ఆ మైక్
So we have helium-4 which is widely available, but we need helium-3 gas which is not available currently. Right, so this is produced by the decay of nuclear waste. So it means you need to contact atomic energy agencies to get this. So that is.
లాగౌట్ చేయాలి, లాగౌట్ చేసి
Right,
మళ్ళీ
so we
లాగిన
contacted them, this is not available, so we have to go out, go to Israel, we go to France, we go
Hey,
to
Lee.
Russia, and try to get that product, and people quote whatever price they want, right, makes it very inconvenient for us to build multiple of these things, right? So the thing is, so now we have given those 2 problem statements to the National Academy of Engineering, so they publish this as problems. Professor, yesterday you heard the lecture from Professor SP University Vice Chancellor. So he took those challenges and published as research problems. There are many other problems, right? Just of time like this. Okay. But we have a lot of new problems that are going on. So complete multidisciplinary engineering and working together only will be able to make kind of solutions, right? And what IBM has now packaged this entire system to something like this. This is the machine that we are going to get it around. So the technology is very, very restricted, so they will not allow us to come close to the system also. It will be put in a glass chamber, and then they will not give access to understand what is there inside. So in the previous slide, I was going to talk about each of the parts or each of the parts, but when the system is like this, you will not know. And the beauty here is most of the systems in semiconductor industry are like this. So if you visit a fabrication facility like SCL, Semiconductor in Mohali. So it's a nice organization with a lot of such equipment coming from Germany and Netherlands and many other countries. It is a black box. You give the input, you get the output. You don't know what is happening inside. So they are outputting of great quality. But if you touch the machine or open the machine, your warranty will be lost. And it's also a government organization is to try to you will also be sent to jail because you are taking the warranty of the product, right? So this is a way of protecting their product. So they are trying to package this product so nicely that we don't know what is happening inside. We don't even dare to open those boxes. If you open those boxes, try to reverse. When you open the warranty was by toss and
ఇయర్ఫోన్ సెక్టర్
and this is a very attractive technology. And what we are doing is exactly opposite. Right? We want each one of you to understand what is going in this one.
ఇయర్ఫోన్ సెక్టర్
Get an opportunity to experiment and try to understand what is required to do this. Right? And this is for the open access aspect that we have at Amravati. And that will give us opportunity to study superconductivity. It will give us opportunity to build better quantum machines. So which will also allow us to build more powerful machines. So those are required, and that's the reason why we have democratized the technology by keeping it open. So everyone can actually visit the facility and understand and see what are the technologies that are inside. Otherwise it would have appeared like this. And you see the so this is one thing that because you're all coming from the research faculty. So now when you think about systems, so think from multidisciplinary perspective and think your research is always part of somebody else's system. So it goes as an input to somebody else's system. And then you put all multiple inputs like that to make a complex product. And
Apart
that
from
investment is not replicable, and that creates economic output. Okay, I'll just briefly touch upon some of the interesting things that are happening in India. So the way we are doing this session today, first I'm very glad that we're in the state we're talking about research. So next time whenever I want to talk research, I'll come here. So this is about the India research initiatives that are happening through National Quantum Mission. So Prime Minister's under the leadership of Prime Minister, so we have 12 national missions that are going on. So the new missions keep adding every year for the new mission that is being added, by the nuclear mission that is coming. But there are 12 strategic missions like this. So National Quantum Mission is one of the important missions. So it is a 6,000 crore initiative. So that is run by Department of Science and Technology. So Department of Science and Technology, you must be knowing, so they run a lot of research programs, collaborative research programs with foreign countries, and they also give a lot of grants, fellowships, etc. So, but National Quantum Mission is one such important program. So here, so what happened is, so they now started with setting up specific goals. And okay, so we need to build.
అందరూ మెయిల్ ఇది రావచ్చు
We need to build a satellite
దాని వల్లే ఇందులోని సేమ్ అదే
fiber-based communication which can handle 2,000 kilometers range of quantum
Yeah,
communication link. And then we have the quantum
Yeah,
communication links of 2,000 kilometers. And then there are 500 meters atomic clocks, high sensitivity and precision instruments. And then we also develop quantum materials. So these are some specific goals of the mission which started. So and then what government of India has done is they created 4 hubs across 4 regions, 4 universities. So the first one is ISA Bangalore, which looks after all the computing team. So what you can do in quantum computing model. That is one of the important hubs. And then take this one. So we have another hub which looks after quantum communication technologies. So quantum is significantly used in communication. So I'll come to that, right? And then there's the third institute, quantum sensing. So there's a third area, important area where how do you make quantum sensors. And then we have quantum materials and devices. This area is we also all other groups by providing required technologies and materials that can help in building other quantum fields. So this is how the mission is constituted. We are 2 years into the mission. So out of the 6,000 crore, about 3,000 crore is allocated to different institutions, and we are getting a lot of common facilities and national facilities. About institutions have won this proposals. Researchers are engaged into it directly, and about 1,000 researchers are engaged into this mission indirectly. So we also support other research groups. So, but this is a coordinated national effort. So here, each proposal is, of course, all the new proposals that are coming from EST are like that only. Right? It involves a collaborative effort. So you have a lead principal investigator member together. So the program is focused centered like that only. So each project, so there are 17 projects in total across all these 4 teams. And each of the project has got about 7 to 8 members who are coming from different institutes together and working on common technology. And it's a truly national effort. And the truly national effort has actually come out as an output in the computer that we have seen. So where some of the PIs who are members here in these hubs have actually contributed to building the quantum system. So all these institutes are part of it. So let's see on so we have to look at there. We're not seeing many proposals because of the probably there is not much awareness at that stage. That stage of call for proposals. The National Quantum Mission was also surprised. By the first set of this meeting, February 2024. So they thought only 300 people from the country will come for that meeting. So suddenly some 800 people turned up for that meeting in Delhi. Right, and they have taken a hall like this for 300 people. But finally they have to accommodate 800 people. Right, so it was an organizational nightmare. Dr. Reddy was actually managing the logistics. So he organized the function so well and engaged all the 800 people into the mission. So there were 384 proposals.
Ice cream on the Kotaka.
But they've selected a few of them which are very targeted towards
Allah
mission.
we ST.
And then all these institutes contributed to some nice proposals. But still there are a lot of other proposals which are
Yeah.
very valuable and the evaluation is going
At the
on.
rate?
So we have more new teams that.
2008.
So, so the efforts from research in the country level are now happening in this model only, right? It's all collaborative research, right? You have to collaborate with some professor at other university.
First
India,
capital
outside,
of Canada.
and together you have to formulate your problem statements.
The
and then
captain.
act and problem statement, right? And the same thing is there with other proposals that are coming, right? Some of you must have submitted proposals for ANRS position or the new RDA fund that is coming. The RDA fund that is for facilitating the startups and companies and also the research institutions which are building products at for the government of India will give a matching grant and a patient capital to take these products to higher tier levels. So those technologies are also all based on the same theme. So we are now all the proposals coming from the national are based on the collaborative effort from DSC. So now the mighty proposals have also started coming like that. It is the Ministry of Electronics and Information Technology. So they are also handing out the collaborative proposals. In fact, recently, so on cybersecurity, there was one proposal which mandated 30 crore funding for universities, the law university at the time. So this is very strange, actually. Law university got that this can be done, right? But now they have submitted the proposals. So research has changed a little bit here, and our effort will also be like that. It's coordinated and then work together. Okay, so I have two products where there are opportunities. So these are the technology teams. There's the very things here. So in order to right now the money is all in research, right? So research of making these quantum computers, quantum communication equipment, quantum sensors. So it is not on the applications yet. 1995, so in software world, what we have done is started somewhere in the computer and we started writing applications on it. And we created a good number of jobs and then a lot of applications have come out. And we started building interesting areas like cloud, distributed computing, then artificial intelligence, and then associated applications around it. And where we are focused on hardware, we went on building embedded systems, so which we translated into building better cars, better refrigeration systems. So here, in quantum, the opportunity is right now in building some of these core technology things that goes behind it, right? And we have set a goal for India. For that, we will manufacture most of these components. So this is the national goal. Right? And this is where we all have to contribute. So we can buy these products from companies which are already there and they're doing very well and they're working very hard to sell these products to the country. But now what we are looking at is making this entire dilution refrigerator in the country. So today there's one company in Finland that holds a monopoly of this one. So India placed order for 15 such systems, right? And the delivery cycles are after 1 year. So which means you yourself will not be able to do research even if you want to do, because they will deliver the product only after 1 year, right? And now just imagine, given the geopolitical situation, if they put a embargo on transferring this technology to you, like you order a diode and see, laser diode and see, right? You not get it, right? And after that, you struggle for 6 or 7 months, and then you take support from government, and then you may get it, right? So these are technologies that are very strategic, and people are not giving it. So it is important that we need to build these technologies in India. And that is where we are putting all the efforts. When we all have to put efforts in building these technologies. So one on the cryogenics, so a good amount of opportunities. So after this unlocking machine was launched, so there are some new opportunities have come up. Actually, we never realized that these were the asks that are going on. So there are many nanotechnology research centers in the country, so which are building new materials. So they have never tested their materials below minus 70 degrees. Right, and suddenly all of them have started approaching this company saying that I want to test my material at minus 273 degrees, right? And this is completely new area. We never know actually. Maybe that could result in one of the Nobel Prize winning ideas. You created the material, but you have not done the characteristics study for that material at lower temperatures. So today you have to send this to other countries Netherlands or somewhere and get this study done. And that is expensive. You have to book the system, wait for the system to be available, and then use that system. Right, so that is very expensive. Now, we need to, once we build a system like this in the country, then you replicate some 100 systems like this at different parts of the country, and you have these research facilities available for everyone. And that's when you can do a lot of industry. So this is an area that was good opportunity for building technology here. So it's not just minus 273, there's opportunity at 4K electronics. You also, in fact, we were working with the defense research. So they were doing their night vision systems, which are operated, which also uses cryogenics. So they said we don't go to this low temperatures, but now they have floated it RFP per minus 273 degrees centigrade. So there are a lot of work is happening here, and associated instrumentation that goes in, like the cryostats, compressors, the vacuum chambers that are there. So today, the quality of machines that are coming from Germany or Japan is very high, right? And we don't have any equivalent versions of them in India. So that itself is an opportunity for all people working in mechanical engineering. So it's an area that we can look at. Okay. And similarly, we have this instrumentation. I think for some reason we have taken granted that only that Nigerian company or Keysight company systems work much efficiently than any other technology, right? And this is something that we need to change actually. And here the best part is with quantum systems are also made open source by the companies. So the designs are available. So all we need to do is make systems which can be used in controlling quantum computers. So we need some electronics engineers who can build all these bits. So JNTUK partner as one of the labs. So we are going to set up some of these instruments here. But the goal should be to build the instruments ourselves, actually. So we have to build the instruments. Then we have photonics. So this is another interesting area. So here a lot of technology development is happening. And there are also success stories from many startups who are building this SPADs and SNSPDs. Again, SNSPD operates at 4K temperature. So here, the opportunity for a lot of innovation as well. You can create a lot of new sensors, maybe medical diagnostic devices or food diagnostic devices. So I think that's what this building the technology here. So this is an area that we need to build indigenously. Lasers, again, I told, so this is the difficult part, we cannot get it. The wavelength that we require, the quality that we require, and also the characters that goes into this one. And this is another even technology, but we again depend on quantoms. So cameras are under so significantly used number of cameras in this photonics. So this is another area we completely depend on outside world, right? So these are all the areas that we need to build. So and once we build this indigenize and then put them in the hands of people, so you very difficult to import also. Actually, these photonics lasers these are very tricky, and these cameras are fine, but some high speed cameras and all those things are very expensive. So there's an opportunity to build all these things in the country, and this is the effort that we need to put. And some of them are very easy. That don't have to post actually. So we need to build these technologies, and this is one of the important pillars of quantum machine. So these are some examples of Indian teams that are working on quantum. So this the first one is a startup based out of Bangalore, which has built this 25 qubit quantum machine. Second one is IIC Bangalore with the photonic quantum computer. Third one is the mostly and with the professors, IIT Delhi, he works on gravimeter and then electromagnetic quantum computer, and this works on trap ion quantum computer, and which is who's the head of IIC Bangalore hub, and also builds a photonic quantum computer. Yeah, so the point here is all of them have good number of PhD students and graduate students working under them. It's a very nice ecosystem that they built together, and they are able to deliver products. Products would require a little bit more high quality, but we are in the process, and all of them have got funding as the quantum. Quickly into the applications, just because we're talking about quantum for long, but you don't know the application, then it's a problem. But again, just directly jump to this slide. So because this said the speeds are, you can accelerate computing at the speed of exponential power or quadratic power. So you can accelerate anything with this, which is AI. So whatever AI we are saying today, so you can significantly accelerate that algorithm. One example that I'll give, which I worked on, so we've taken a unit model. So if some of you, if you're working on segmentation, image segmentation or image anomaly detection, there's a very nice deep learning algorithm called UNet. So, and the unit algorithm can be transformed using quantum. And then you can modify some of the layers of the unit algorithm and then put them on quantum. So it not only accelerates, the algorithm also converges very fast. And then you get better results in terms of accuracy and speeds. So both are possible. So which means anything with respect to AI, so all the AI that we are talking can be accelerated. So all you need to see is like some algorithms are good on CPUs, some algorithms are good on GPUs. So working on LLM. So you know that it is very good. It runs very nicely on CPU. So if you're working on say image processing algorithms, then you actually put them on GPUs and you get the efficiency. Similarly, you have to know which algorithm to put on quantum, right? So this is where all the opportunity is. So most of the enterprises are working on this now. Then quantum is used to solve this optimization problems, extremely complex optimization problems, like Amazon delivery, right? So today in Amazon delivery, so the driver is always given a chart saying that you go this route, but how the driver himself is selected is the process. Right? So you have to choose the size of the truck, you have to choose the size of the packet, select the driver, you have to identify the customers who you should visit, and to sequence those customers, and you should also, there are some constraints like that customer is available at only that time, so you need to deliver before that time, right? So these are all individual problem statements of optimization. And today, no computer can solve this individual pieces of all computers can solve these individual pieces of optimization, but no computer can solve all these things together. So that is where the quantum computer can play a role, and that is where quantum computer is good at. So solving the entire problem at once. So you get any complex optimization problem. So the quantum computers are good at solving this kind of complex, extremely complex optimization problem. Other example, real world example. So the Canadian company that is working on sequencing and loading of their containers. Right, in a railway yard, you have a bunch of containers stacked nicely. See that in the ship also. And you have to pick these containers and put it on a train in an optimum way so that the train utilizes less amount of fuel. That is the problem statement. So they're able to solve this problem only for 100 containers. The problem appears very trivial. Every human mind can do it. It will appear like that, but you need to apply a very complex mathematical model with a lot of constraints to get into the full level of optimization. So that is another optimization problem. So in power, so we have now very interesting grid models, right? We are producing solar energy, then putting it back to the grid, and then we're also harnessing other forms of things, and they inherently, because of the environmental conditions, it follows a depth curve. And now when you put all these things together, it again becomes a complex problem, and you have to optimize it for price, right? So that is a complex problem. So companies like many companies are working on this problem statement. So we have problems in chemistry, which are like new molecules discovery, or studying the new molecules using the methods like DFT and others, are all possible with quantum. And sorry, sir mentioned about personalized medicine. So here we are going to the next level, right? We are creating a digital twin and testing out all the medicine, right? And this is possible with the quantum simulation. So we have many problems that we can solve. So a lot of interesting activity is going on, but none of the quantum computers that exist today can solve this problem with a return on investment, right? So we need much more powerful quantum computers. So 1,000 qubit plus quantum computers are required. That is when we have to wait another 2 years to get this 1,000 qubit quantum computer and we can do all these problems. Today, so this is used by all these organizations. So they're all given some examples like quantum events to design battery materials. The CERN, for general super rankings, or their particle calculations. So they're identifying patterns for the data. So Boeing uses for this loading and sequencing problem, and then also building lightweight materials. Beyond the energy company, which is energy pricing, again chemicals, so plenty of opportunities. Each of these companies are working, so each of these can be a research problem. Actually, each one is modeled as a research problem. So how companies are done this technology? While researchers have some luxury, so companies don't have that luxury, right? So I'm working at TCS. My boss keeps me asking, so what is the value? How much money I can bring with this solution, right? So we don't have the luxury. So we learn fast, move fast, and then while the research team builds this technology for some time, the innovation and incubation team struggle with this, putting this language. The way organizations also learn today is through hackathons. So they wrote these problem statements as hackathon problem statements. For example, so this is the Airbus VFW quantum challenge. So it's a smart coding problem. So it's a mitigation of corrosion of aluminum surfaces by quantum methods, modeling the absorption of inhibitors. So this is a true quantum problem actually. I'm sure one of you must be solving this problem in a different range in AI. Right? So same problem I see then model this in quantum. So again, we have also done a global quantum challenge
Kartik, chalo.
at TCS.
पास गया
So here
चलो,
again,
plus का
different methods.
कैप एट को
Identify
Kartik
different
को
problems and progress. Global challenge
और
of
कैप
research scholars participated in this problem.
एट
Deloitte launches every year their climate challenge. So again, they give the data of reverse flood prediction and to do the efficacy of disaster. So these are problem statements that are available. So plenty of problems that we can solve with quantum. Take one of these. So again, just to end this, so a lot of opportunities in this space right now. So the top two candidates ratio is 3:1 right now. Not many people understand quantum, so these are here. And that's the reason also why the state is interested in it and the financial things. So we have good growth rate in number of jobs. It can create a $1 trillion economy on itself. But if you have seen the previous quantum computer, we must have seen multiple technologies going on together. You also see the jobs currently in the area of fabrication, assembly testing, to quantum energy, cloud platforms, so you have multiple kind of skills that are required. So these are all the jobs that are listed on QGC website. So you can go and see what kind of skills that there are. So we said there's good amount of quantum power that we are creating, but there's also one challenge if this falls in bad hands, right? Today all of us are using WhatsApp. It says your messages are encrypted, but encryption is nothing but a mathematical model. So what happens if I break that encryption algorithm using another quantum computer? And last week, one company that announced I can also network these quantum computers. So which means I have say 130 qubits. I can put multiple such 130 qubits and create a bigger machine. So if you put all these machines together and launch an attack, you can easily make these algorithms. And there's a scientist by the name Peter Shaw who has shown that you can do prime factorization very easily with quantum computer. And then he has demonstrated that this prime factorization can be broken. So that has resulted in threats for everyone. So which means people were wondering, okay, so in 2033, my data is exposed, encrypted data is exposed. Somebody has a quantum computer to reveal that data, so it can put all of us at risk. Right. So that's the reason why we also have some opportunities here. So government of the NIST, which is the US National Institute of Standards and Technology, they have created new schemes. These are the new encryption schemes that they have created. And also put a regulatory requirement saying that by 2030, everybody first get migrate onto these new encryption schemes. If any of you are from the computer science and cybersecurity background, I think these are good areas to work. So if you have to create any of these encryption schemes, or you create India encryption algorithms. In India, we have very handful number of cryptographers who can create new algorithms. And right now in all our computers, we inherently assume that the encryptions are safe and secure, right? But we don't know what a computer can make all those things in future. And not only that, you should also be protected from other countries, right? So that's the reason why you should also have your own encryption schemes as a nation. And there is an opportunity here to build new encryption schemes. There are a few professors who are working on it. So IIT Kanpur, couple of professors. So one of their algorithms is used by Korea as their nation's algorithm. Right, so some good work going on in this space. So there are a lot of research activity going on here. For startups, there's a lot of play here again. So most of these encryption schemes, your WhatsApp encryption scheme should be migrated to a new scheme before one of these schemes, right? So that itself is a huge effort for an enterprise to migrate all their applications onto new schemes. So that results in a lot of opportunity. And the best part here is we also use quantum technology to build new communication systems which are more safe. So today, if somebody taps your data, you don't know, right? So you're connected to your Wi-Fi device, but if somebody taps the data between your phone and your Wi-Fi, so you don't know that somebody has tapped the data. But quantum gives that ability to identify somebody is tapping the data also. You have used quantum effects to identify and measure those data transmission because of some of the quantum principles like no cloning theorem. So you identify that somebody has tapped into the network. So this is where we need to build better systems. So all our different systems should be protected with technologies which are protected with inclusion. Today we, due to the limitation of our cables and wires, so we don't have that ability. But quantum gives that ability to do this. A lot of companies that are working on it, they are good organizations that are there. And last item is sensing. So in the National Quantum Mission, one of the things is sensing. So what we are trying to make to this shift away from this bulky MRI machines to translate to a small helmet. Right here we use a technology called nanosecond diamonds, which goes into the helmet. They are activated in the laser. So it generates magnetic fields and we can measure ultra precise magnetic field. So the same this superconducting magnet based MRI machine will translate to a helmet in future. University of Nottingham is working on this technology. So they're also manufacturers of MRI machines. Now they are making these helmets. So now let's imagine if this is going to on the healthcare workers, then actually do brain mapping and I'm sure some of you must be working on brain mapping studies also as a research project, right? But you would require going to an MRI machine actually making technology like this. Right, and then there are other opportunities here. So we have better clocks that can go up to the frequency of 10 power minus 19th of a second. Then you have quantum magnetometers where you can do better subsurface inspections. Magnetometers you can do physical mapping. Gravity which you can arrange for navigation. Then better electro mechanical sensors that are possible. So a lot of opportunity of sensing as well. So these are the things mainly primarily. And finally, again, while all those things are technology, so but we have to make these things real. So to do this real at Amravati, we are building a world-class ecosystem. So this is the Water Valley, so that is coming up. So we will be the 9th country to have the state-of-the-art water machine. You should be proud of it, and it is an investment by TCS and IBM. So this will be the state of the art machine that is going to come here. Right now, this building is under construction. So this will be done by October 15. And this building will be hosting a computer and a small incubation space where researchers can come and work. These two towers are starting. So last week I covered construction of these two towers, and then works will start quickly. And then we have another 6 towers that are coming. So it is a 9 million square feet of space which can accommodate 88,000 people around 50 acre campus. Right, and we hope to see these first two buildings coming by 2028 mid. And this should be operational immediately. Total 8 towers. 8 towers. And Krishna River is on behind this last tower, about 1 kilometer away from campus. So on the banks of River Krishna, so we will see this. Next to this one, we will also see a big Spilani campus coming up close by. So this infrastructure, in all these buildings, the water flows are reserved for setting up labs. mainly for hardware, components, manufacturing and assembly. Because we've been always thinking everything is software, so we don't construct our buildings like that. So, but this time, all these bottom floors are reserved for setting up hardware and manufacturing companies, mainly assembly. Okay, so that's the way in which this is conceptualized. Uh, and then broadly the vision is defined as 5 pillars here. So right now work is happening in 5 teams. So the first thing is getting these buildings. So the building should be ready by 2028. The second pillar is hardware and hardware components and ecosystems. So it's mainly building the technologies that go into quantum hardware. We are engaging about 76 companies who are working with us on both hardware and software. Many of them in hardware right now. The third pillar is research and innovation. So this is where we are working on software part of it. Once you put a computer, it is of no use if you don't know how to use it, right? And these are complex technologies, and we have a different way of programming this machine. So what we are trying to do is now taking this capability to the ground. So we are organizing a series of sessions with IBM and all the experts from India who are working on the state-of-the-art quantum machines and trying to get this knowledge back to the ground. So many of you must have attended some of the courses by NPTEL and Pfizer and the effort from MNIT Jaipur for FTP programs. So the idea is to use this machine 133 qubits and then we do some interesting studies. You have to simulate a copy molecule. So you should, so all the computing power that exists in the world today cannot simulate a copy molecule. Right? You cannot simulate anything more than 50 qubits in any form. Right now you have 133 qubits, which is significantly powerful. You can actually do a lot of interesting things. So many drug discovery companies are using high-tech compute to build the new molecules. In fact, what they are doing is they are taking all their off-patent drugs and giving it to young startups and then asking them to study how do you build on quantum so that they can learn from the startup and again do the big enterprise. So that is what is happening in Germany. Right. So the third pillar is on the research and innovation. So here we have engaged our academic ecosystems. We also have initiatives like Biofoundry, banking and finance cluster, then quantum operating system initiative. So these 3 initiatives are going on. And the fourth pillar is companies that are coming into the valley. So we have some nice companies that are coming there. Target is to get as many companies as possible. So we should reach about 100 startups in the next 6 months. And then some top companies setting up there. So we already speak to companies like AstraZeneca, HCL, Loras, HDFC Bank. These are Indian foreign companies. We also work with a lot of multinational companies. So all these companies are expected to come soon. And at some point, if you build this as a top 5 global hub, so they will have to come here. There's no other opportunity. There's no other chance to them. And the last pillar is talent development. So it's 5 teams on the talent development side. So we're training good number of people on quantum foundations, but good number of people also on advanced and allied program. Our target is to have some 5,000 experts in the coming 2 years who can be suitable for working at any of these multinational companies. So that's our objective. So these 5 teams are going on at Conclave right now, and that is what my team is busy with. So we don't work on any of the technology directly, but we facilitate and enable building all those 5 teams here at Conclave. So we also have 100 crore Nobel Prize that is declared by the Honorable Chief Minister. So anybody who makes a contribution that can result in a Nobel Prize, 100 crore prize that is available. And then and for students, I think it's a good opportunity. So a lot of companies in the region are now hiring the students. So if you're following LinkedIn, you see some of the job postings. The startups are hiring in the region. So our goal is to keep costs very, very low for the startups right now. We are taking all the necessary measures to make sure that the startups get benefited with low cost region, but this is a high inflation zone, unfortunately. And the idea is to develop the entire hub as quantum valley. So it's not just that 50 acre land, but the entire region will be called as a deep tech hub that will be focusing on 4 things: quantum, AI, cyber physical systems, and semiconductors. So these 4 teams will be there at this quantum valley initiative. So our goal is to build that entire region of Vijayawada, Amravati, Guntur and other places, surrounding regions as a deep tech hub, and that entire place is called Water Valley. It's not just those buildings that are there. So that's all about the quantum technologies and what's happening in Quantum Valley. And I see some of your board with this. But I hope you got some insights into the story. Again, the point here is we can build these technologies. So many times we struggle to explain people that we should not wait for somebody else to build this machine and then we run algorithms on it, right? And that is what is a mistake that we did in the past. And this time we don't want to do that mistake. We want to build the machine itself. So Honorable Chief Minister had set the goal that we should build these quantum computers from Amravati. 85% of the components should be built from Amravati. And then we have to spread these components across Indian research institutions so that we can build better products. And then these things, once they are available in hands of Indian researchers, obviously the research outputs will be better. And that is the goal. And that is the goal for this room also. We want all your support in making this initiative happen. And under the leadership of Sir, who has already set the directions for how to do research and how to organize the institution. So with this one, you take some of the challenges that are coming here, or if you have challenges, please let us know. Okay, and any problem that you are doing in AI is a problem of quantum value, right? You can also give problem statements. The state government has already provided multiple problem statements from the departments, which are extremely complex optical. Similarly, the banks that are working with us, pharma companies that are working with us have provided problem statements, and these problem statements are available for all of you. If you want to pick up a problem statement, I'm sure when you pick your research area, you are already choosing the problem. But when your students are doing this, please come to us. We'll be happy to share a lot of problem statements that are available. And these days it is very easy. Government of India has done some wonderful things to make sure that these problems are available to Smart India Hackathon, the defense, IDEX challenge. All these challenges are being very, very real world problems these days. And some of the ANRF mission problems. So those are really, really interesting and complex actually to handle those challenges. So I think we've solved some problem of doing this entire cycle. We did not look for problems. The problems are there. And now we look at opportunities on how to address those problems and then build great systems, better systems. So that will help India to create an economic engine and then make all our students employed meaningfully. So that is also important, right? So and ensure that the students are not stopped at learning phase itself, and then they go towards experimentation and exploration cycle along with you, so that the jobs are anyway guaranteed because you crossed that phase. Right now, you set the goal as getting the job, so that is a problem, right? So when we get a job, we feel that is great. That is the greatest achievement of life. But that's where the problem is, right? And then move further towards the experimentation cycle, and we can do all these products that we will discuss here. Right. So with that, thank you for giving this opportunity, and thank you for taking the time to attend this lecture. And thank you, JNTUK, for having me here at this forum. Thank you so much.
Dear participants, any queries?
Any questions?
Any question from anyone of you? Yeah, please.
Good afternoon, sir. Thank you for your wonderful lecture, sir. Sir, I have a problem. My program requires thousands of qubits. Now, where can I execute it? Like, can you please suggest me?
Absolutely. So this is not only your problem, this is also my problem, everybody's problem who's working on quantum software today, right? Today we have only 133 qubits max. Right? So, and what we are saying, so just like Moore's law in electronics, so here we follow something called Gauss's law. here the quantum volume doubles every year. So 150 qubits will become 266 and 1000 soon, and a million qubits soon. And we'll also do the networking. So which means looking at long term, but right now many of the problems, right? So the same thing happened for me. When I went to NCL, National Chemical Laboratories, so we were explaining quantum to them, saying that this is the new technology, you need to embrace it because you are the best research institution of the country, working on chemistry. So first, they're correct. No, whatever problems you're talking are 2 atoms, 3 atoms, and all those things. We are working on 1,000 atom problems, right? So, and the quantum computers that we're talking are small number of qubits, which is not solves, not possible to solve that 1,000 atom molecules, right? And then we stop the discussion there. But 2 months later, they have done their research and they've come back to us. They said actually that we want to understand this technology from you and learn these problems. Right? We can do a lot of sessions for them. The opportunity here is the hybrid computing in the near term, right? So you need to break down that problem into place where what is good to run on CPU, GPU, and the quantum processor related. So you should not put the entire problem on GPU. In the short term, we will be living in that cycle. But eventually, in the long term, once we have 1,000+ qubit kind of systems, we'll be able to model these problems better. And we're also looking at networking these quantum computers, right? And that's when we'll have a lot of qubits that are available, right? So it's good to know that you are working on a problem that is requiring huge number of qubits. I would actually like to sit with you and take that problem statement and wanted to give it to our groups which are working on this problem statement where they would require to visualize problem for 1,000 people. IBM is actually really interested in this kind of problem statements. Last week we did a workshop at Amravati with IBM team. The idea is to identify these kind of problem statements. So again, there is also another problem that many people can't think of a problem that requires more than certain number of qubits, except in pharma area, right? In pharma, all problems are require higher number of qubits, right? But in other areas, we don't know exactly what kind of estimation we need to do and how many number of qubits are required. That itself is a research problem, right? And these machines are expensive to access, so you can also apply more logic to optimally utilize and do it. Just another data point. So IBM has given state government 365 hours of the machine usage per year, and this will be available for all professors available in the state. So that's another data point. So if you have a problem statement, actually you can bring that problem statement to us or me, and we will try out that problem on the ideal machine once that is installed. The machine will be installed by December 31st. Thank you. Any other questions?
Sir, is that true that people who are seeking employment in quantum computing should have good knowledge in physics and hardware, little bit computing? Is that true? We're under the false impression if I'm.
No, this is a completely myth. Okay, and false.
Thank you, sir. Thank you
It's
so much.
better to have some knowledge of physics, but it's not required. It's more of computing, a different way of thinking, doing parallel processing.
So everybody can afford it.
So yeah, this is one best subject that everybody feels personal to themselves. Right from the physics team thinks that quantum is their subject. Biology team thinks that it is their subject. Chemistry team thinks that it is their own subject. So somehow chemistry thinks that they own it actually.
Thank you, sir.
Computing guys will think that it's their subject, right? But it's not required. So many of the things that we spoke about are multidisciplinary, like sensing. So we have to do sensing to identify those sensors and then work around those sensors. You need multiple skills, not just quantum. Quantum effect, once it is known that a NV center diamond with nitrogen and another vacancy, when it is hit with a laser, it acts like a magnetometer. That's it. That is the principle that we need. Once we know that principle, we actually need a lot of electronics knowledge to actually convert that into a nice sensor.
Then can we conclude that it's land of everybody?
Yes, it is.
Thank you, sir. Thank you so much.
Thank you, thank you.
Thank you, sir. Say memorable lecture. Now I request our Honorable Vice Chancellor, sir, please come on to the dais and felicitate Sridhar Singh.
Thank you.
Dear participants, thank you, Vikasit. Now I request all join for lunch at the same place where we have provided last 2 days. Then afterwards, electrical department people need to go to the electrical department and present posters. Civil engineering, physics, chemistry, management, library science. All these people need to go to the Department of Civil Engineering. Okay, ECE, Department of ECE, Mechanical, Department of Mechanical, CSE and IT need to go to Department of CST. Again, we will join here at 4 p.m. to receive prizes. Okay, jury members. Once we receive the reports from the jury, we will issue prizes for the best poster presentations. Thank you.
Conference. Good afternoon. All right. All right. That's what I said. That's what I said. That's what I said. మనకి ఏమైంది వస్తువులు వాయిస్ ఏమైంది సార్ అనిపిస్తుందా నా వాయిస్ very extremely okay. So now know that there is the technology day for organizing the research program. Okay. So diverted weather TV of the quality report. So the actual meeting is called for extension of the export. Here, the state government has the 8 back advertised. Now, since JNTUK Vijayanagar has not advertising the post belonging so firstly, I'm trying to distribute to the different again international. So that means that instead of 8, we are going to test 48 vacant. 48 paying once again with it to the various now done. Hey, Babu, ever Jonathan, you can understand it. So let me explain. We have about 197. This is the complete picture about our JNTUK partner. Right? You see, page 119 posts were sanctioned by the government of India. For UCM, 78 posts were sanctioned. Department-wise distributions are out. And grant-wise distribution are also there. And the campus. Campus. Pinna 8 తెలుసుడు చేయాలా ఏంటి కాదు చేస్తే సంపించారు పక్కన తీయడం లేదండి వచ్చిందా థ్యాంక్ యూ సో మనకి కొంత పోస్టులు ఉన్నాయి జేఎన్టీయూ కాకినాడలో యూనివర్సిటీ కాలేజ్ ఆఫ్ ఇంజనీరింగ్ కాకినాడకి, నరసరావుపేటకి 78 ఉన్నాయి. పోస్టులు మనకి 197 ఉన్నాయి. ఇది ఎగ్జిస్టింగ్ పోస్టులో కింద మనకి 76 పోస్టులు ఉన్నాయి. ఈ మధ్య విజయనగరం నుంచి మనకు 19 మెంబర్స్ వాళ్ళందరినీ యూస్కెన్ కేంద్రం చూపించాను. ఇట్ డజంట్ మీన్ దట్ ఆల్ ఆఫ్ దెమ్ విల్ బి పోస్టెడ్. అంత ఓపెన్ గానే మాట్లాడుతున్నాను. అయితే 9 మంది అక్కడ పోస్ట్ చేయాలనేది నాకు నేను అప్పుడుగా సో then I took the hands of the many people. So కొంచెం participation. I'm going to ask all these 19 people choice between Kakinada and Hyderabad. Take the choices from these 19 people. From the availability of the vacancy, Kakinada and Hyderabad. They will be registered within the Kakinada and so I accept Jason. So this is the time people don't think that all of them are posted. So 19 members to JNTUK given into as on today, JNTUK members. When it is 197. Post to 2023 లో మనం అడ్వర్టైజ్ చేసాం మన యూనివర్సిటీ. దేర్ ఆర్ లైక్ 8 పోస్ట్ ఉన్నాయి. సో గవర్నమెంట్ ఇప్పుడు మనకి చెప్తుంది 8 పోస్ట్ ఆల్సో అడ్వర్టైజ్, నాట్ అడ్వర్టైజ్ వితౌట్ వెరీ మచ్ చేంజ్. 2023 లో మన అడ్వర్టైజ్మెంట్ ఇచ్చినప్పుడు బ్యాక్ పోస్ట్ ఇంకా సో అజ్యూమింగ్ దట్ ఈస్ 8 అరౌండ్ existing దానికి బ్యాక్లాగ్ పోస్ట్ కలిపాం. అంటే 95 ప్లస్ 3 అయింది. సో డిపార్ట్మెంట్ వైజ్ వచ్చేసాయి. డిపార్ట్మెంట్ వైజ్ నెక్స్ట్ వైజ్. సో ఎగ్జిస్టింగ్ ప్లస్ బ్యాక్లాగ్ పోస్ట్ కలిపి 103 వచ్చింది. ఏంటంటే మనం కెమికల్ పోస్ట్ ఉంది కానీ మనం అడ్వర్టైజ్ చేయలేము. ఎందుకంటే 2017 లో మన అడ్వర్టైజ్మెంట్ ఇచ్చినప్పుడు ఒక పోస్ట్ టెక్నికల్ చేశారు. అప్పుడు ఎందుకు చేశారో తెలియదు. అప్పుడు తర్వాత ఒకటి కూడా నాకు తెలియదు. నా దగ్గర సమాధానం కాబట్టి నాట్ పొజిషన్ లో గట్టిగా మాట్లాడితే మనం బికాస్ ద గవర్నమెంట్ రెగ్యులేషన్ ఏంటంటే 2017 లో ఏ పోస్ట్ అయితే అడ్వర్టైజ్ చేశారో డిస్టర్బింగ్ కాదు. సుప్రీంకోర్టు జడ్జిమెంట్ వాళ్ళకి రావచ్చు. ఫేవరబుల్ గా వస్తే వేకెన్సీలు ఉండాలి కాబట్టి అందుకని మనం ఇప్పుడు 100% వేకెన్సీలు మనం ఇప్పుడు గవర్నమెంట్. అదే కాదు అన్ని యూనివర్సిటీ 2017 లో మనం అడ్వర్టైజ్ చేసే పక్కన పెట్టి సో దాని ప్రకారం కెమికల్ కన్సిడర్ చేయాలి. తర్వాత ఇప్పుడు లైబ్రరీయన్, ఫిజికల్ డైరెక్టర్, R&D డైరెక్టర్, ప్లేస్మెంట్ ఆఫీసర్, వైద్యసి ఈ పోస్ట్ కూడా ఎందుకంటే మనకు ఒక లైబ్రరీయన్ ఉన్నారు, డైరెక్టర్స్ ఉన్నారు. పోస్ట్ ఒక లైబ్రరీ, నేషనల్ లైబ్రరీ పోస్ట్ అడ్వర్టైజ్ 99 ఉంటారు. నెక్స్ట్ టేబుల్ లో ఆ రో తర్వాత 13th రో నుంచి తర్వాత తీసేస్తాం. సో ఆల్ ది డిపార్ట్మెంట్స్ దే ఆర్ గోయింగ్ టు అడ్వర్టైజ్. సో శాంక్షన్స్ పోస్ట్ 189 అవుతాయి. ఎందుకంటే 5 పోస్టులు ఒకటి, తర్వాత లైబ్రరీ 2 పోస్టులు, ఫిజికల్ డైరెక్టర్స్ 2 పోస్టులు, 4 ఫిజికల్ R&D సెల్స్ అండ్ ప్లేస్మెంట్ IPSC డైరెక్టర్ 4, 3, 7 పైన 8 పోస్టులు మనం పక్కన పెట్టేస్తాం మాట సైన్స్ పోస్టు నుంచి 189 అవుతాయి. 189 లో ప్రజెంట్ ప్లస్ బ్యాక్ క్లాస్ కలిపి 103 లో 4 పోతాయి. ఎందుకంటే ఫిజికల్ డైరెక్టర్స్ లైబ్రరీ 3 కెమికల్ డిపార్ట్మెంట్ అడ్వర్టైజ్ చేశాను. బ్యాక్ క్లాస్ అడ్వర్టైజ్ చేశాను లైబ్రరీ చేశాం కాబట్టి ఆ ఫస్ట్ కూడా పెడితే ఇప్పుడు ఉన్న ఈ 99 కి మనం 48 పోస్ట్ అడ్వర్టైజ్ చేయబోతాం. 99 ప్లస్ 48 140 అంటే అడ్వర్టైజ్మెంట్ వలన 45 మంది కంటే జాయిన్ అయితే టోటల్ స్ట్రెంత్ ఆఫ్ 189% తీసుకుంటే ఇట్ బికమ్ 77.8% అవుతుంది. సో our objective is to make each department లోనూ 78% of the faculty ఉండేటట్టు చేద్దామని దానికని ఇప్పుడు పెట్టాను అనే ఒక కాలం పెట్టాను. క్యాలిక్యులేటెడ్ 31 is the sanction including plus కలిపితే సో 31 into 0.778 కనుక they're getting 24.4. అలాగే అన్ని డిపార్ట్మెంట్ కి ఆ క్యాలిక్యులేషన్ చేస్తే ఇట్స్ కమింగ్ అరౌండ్ 147. టోటల్ షుడ్ బి అరౌండ్ 147. కానీ రౌండ్ ఆఫ్ చేసుకుంటే మనకి ఏమవుతుందంటే 24 వస్తాయి. 147 ఒక కంప్యూటర్ సైన్స్ ఎలక్ట్రికల్ ఈసీ ఒక పోస్ట్ ఎక్స్ట్రా ఇచ్చింది. బట్ ఫ్రాక్షన్ తీసేసి మిగతా రౌండ్ చేసుకుంటే ఎక్స్ట్రా ఏంటంటే 0.1 0.7 కలిపి వస్తాయి. కాబట్టి పోస్ట్ పెట్టారు పెట్టాలి. సో సర్క్యూట్ బ్రాంచెస్ లో మీరు 3 ప్లేస్ ఉంది కాబట్టి allocated to 1 science, 1 engineering, 1 to east. So even the 23.3 ఉన్నదే 24 మిగతా కమ్యూనిటీ అబ్బాయి. So it's coming around 140. So the round up. This is 24 as a district. Present positions plus back class. So for example, civil లో So 24 minus 15 become 9 post, 9 vacant posts. Like a computer science, 24 minus 19. Electrical, 4 minus 4, 10 out. 24 minus 22, 2 posts. So the congrats to Kumari getting 2 posts in the other department. What is the principal? I'm not considering I have to take data from my because she got 2 posts. Only 0 and from my so 2 posts for each. For like a chemistry, advertise study bachelor post. So okay. ఈ బాధ్యత ఒకటి బ్యాక్లాగ్ ఇంగ్లీష్ కావాలి. బ్యాక్లాగ్ ఆల్రెడీ అడ్వర్టైజ్మెంట్ కాకుండా 5 బ్యాక్లాగ్ ఇంగ్లీష్ లో 5 బ్యాక్లాగ్ హెచ్ఎస్ఎస్ ఉండాలి. బ్యాక్లాగ్ లో ఉంది ఆల్రెడీ. తర్వాత మ్యాథ్స్ బ్యాక్లాగ్ లో ఉంది, ఇంకో పోస్ట్ ఎక్కువ. తర్వాత ఫిజిక్స్ ఎడం మొక్కలు ఉన్నారు, 5 పోస్టులు కావాలి. 0 ఉన్నాయి కాబట్టి 5 వెళ్ళాలి. మెకానికల్ 23 9 ఈ ఎక్సైజ్ చేసిన తర్వాత టోటల్ 48 అవుతుంది. డిపార్ట్మెంట్ 9 పోస్టులు, కంప్యూటర్ సివిల్ ఇంజనీరింగ్ 9 పోస్టులు. దీన్ని మళ్ళీ మనం ఏం చేస్తామంటే క్యాడర్ వైజ్ అనుకుంది. ఎక్కడ వేకెన్సీ ఉంది, ఎక్కువ వేకెన్సీ దాని ప్రకారం డిస్ట్రిబ్యూట్ 003 కోసం ప్రతి డిపార్ట్మెంట్ ఎక్సైజ్ చేస్తాం. కంప్యూటర్ సైన్స్ ఒక కోర్స్ కోర్స్ పెట్టాం అసోసియేట్ 0 నలుగురు అట్లాగే ట్రిపుల్ 0 కోర్సెస్ వెస్టర్న్ కోర్స్ అసోసియేషన్ ప్రత్యేకంగా లేదా రెండు బెస్ట్ కామన్ ఫిజిక్స్ అసోసియేట్ నాలుగు వేస్తాం. మేనేజ్మెంట్ 5 ఒక అసోసియేట్ మెకానికల్ అడ్వర్టైజ్ కోర్సెస్ కోర్సెస్ ఎక్సైజ్ అంతా చేసాము. ఐ థింక్ అనుకుంటున్నాను దీని ప్రకారం నవ్వు వరకు కుదరే రోస్టర్ ఎనీ కామెంట్స్ ఎనీ కామెంట్స్ ఫ్రమ్ ఎనీవన్? అంటే 4 hours ఎగ్జాంపుల్ చేశారా? అయితే పెట్టామా? 3 వయసు అదే లాగా 17 ఎన్ని చేసాము తీసుకొని పెట్టాము. అడ్వర్టైజ్ అదే ప్రాబ్లం. థ్యాంక్ యూ. కంప్యూటర్ సైన్స్ అదేనా? ఓకే ఉన్నారు. ఓకే లైసెన్స్ ఓకే ఓకే అసోసియేషన్ కోర్సెస్ ఉన్నారు. 20 4 అయితే 21 అవుతుంది. ఓకే ఇప్పుడు ఒక కోర్సులో కూడా 2 కోర్సెస్ లైసెన్స్ కోసం పెడతాం. కోర్సు లైసెన్స్ కోసం కూడా చూపించవచ్చు. ఎందుకంటే ఇప్పుడు ఒకటి వచ్చేసి 3 పెట్టాం. ఓకే నోట్ చేస్తాం. 2వ 3వ 2 ప్రాసెస్. ఓకే ఇంకేమైనా కామెంట్స్ ఉన్నాయా? సూపర్ 203 Yeah. 203. Weather department comments. The issue was blue was okay, let me explain. First system, someone check again, once again, and repeating. We need to follow process. Because is the unit. So wait, we should have it. Yeah. Okay, good. Very good. There was a debate, some people are saying that, well, I suppose process to మన రెండో మూడు అప్లై చేస్తాం రెండు ప్రాసెస్ సిస్టమ్ మాట్లాడాలి ఏంటంటే ఓన్లీ పార్షియల్ టోటల్ పోస్ట్ గా తీసుకుంటే టోటల్ నెంబర్ ఆఫ్ అప్లై అది మనం అసోసియేట్ కూడా సేమ్ నెంబర్ ఆఫ్ అడ్వర్టైజింగ్ రెస్టారెంట్ పై కోర్సులో మనకి ఏమున్నాయి నాలుగు అసోసియేట్ ఇప్పుడు ఏంటంటే ఎగ్జిబిషన్ కలెక్టర్ తీసారు చూడండి పర్టికులర్ చేశారు కంప్యూటర్ సైన్స్ లో 4 3 అవుతున్నాయి కాబట్టి గతంతో వెళ్ళిపోతుంది డిపార్ట్మెంట్స్ అన్నింటినీ ఆల్ఫాబెటికల్ ఆర్డర్ లో పెట్టుకోవాలి ఇది Let me explain. ఉన్నాయి కాబట్టి 15 పోస్ట్ 100 పాయింట్స్ లో ఎక్కడెక్కడ ఎస్పీ పోస్ట్ వస్తున్నాయి 2 7 22 5 52 దాని ప్రకారం ఏంటంటే ఎస్సీ కన్సల్టేషన్ ఏ గ్రూప్ ఏ 1%, గ్రూప్ బి 7.5%, గ్రూప్ బి 6.5%. సో గవర్నమెంట్ మనకి ప్రకారం ఆ రెండు ఎస్సీ పోస్ట్ కాబట్టి 2 SC1 అంటారు 7 22 41 42 6 సంవత్సరంలో అంటే 16 దీని ప్రకారం మనం By Ganesh. So, hold on, wait. But then, regarding to prepare and those and the. And then there's who need to give the advertisement by thing. It is work done or work. They 2-3 times were in that advertisement was cancelled. 23 advertisement cancelled and all that is the big he said the website of the government on the units for the universities. Even Malama instead of it, then without the government. As the pay, it's on the we are supposed to the withdrawal of the advertisement has government. So next step is on this one. They're sending this question on state government on this one. They want to provide this to the department of Congress. First welfare department. JC commission department. The process is we are to discuss in the department committee for the vacancy questions on the number of posts and similarly board of studies. Only time and government possibly to the board they have a committee and board of studies. Now, time of the matter. They were already done. Yes, sir. This is while waiting is my bonus. Then again DC, US, as in as to economic board alert. Meeting the Alpha Jacob, Sandro. Tomorrow, in the morning, right? The BOS. Other than the morning, but and in economic Senate meeting, but that will come to and tomorrow evening, send it to the east. Then we have to go for it. Right? The morning will remind here BOS. The academic Senate. Okay. The evening resolutions of the academic Senate and to the east. And please cooperate, please communicate. Answer, this is a communicate. Tomorrow, not that. Yes, Physical. Here in the US. The university level. I mean, fine. I'll explain the complete. Have any now or have something for others all the others not do any, they should not do any lab. Should not do anything. That's the idea. Something comes to your mind or have any observation. That's in the world. Okay, thank you, Honorable. Have a good lunch.